Welcome, welcome everybody who is seeing me. Unfortunately, I am not seeing you. If you are seeing me, hello, welcome, and please ask your questions. Good afternoon, good afternoon, good afternoon, Shantanu. Where are you from? I'm not able to hear. That's too low for my. You are able to hear? Okay. I have to face. I have to look at the. Oh, Tripura. Very nice. Welcome again. Good afternoon, Nexi. Where are you from? Hello, Muhammad Sadiq. Oh, Nexi from Guwahati. Welcome. Muhammad Sadiq from Kerala. Very nice. God's own country. My TA is also from Kerala. Shrikant, please come. Say hello to Sadiq from Kerala. Hello, Subrat. Welcome. Where are you from? Dipankar Panda. Good afternoon. I'm IIT Rourkela. Then just say hello. I'm also happy saying hello rather than answering questions. Yeah, from delayed. Yeah. Khushbu, you want to say hello? My other TA, Khushbu. Hello, everyone. Hello, Abhishek from Jamshedpur. Welcome. Uh, Regarding the syllabus, actually, I have not checked myself. Do you people have idea, Khushbu, Shrikant, regarding whether what I am teaching covers the GATE syllabus, physical and mechanical metallurgy in the GATE syllabus? Working. Yes. He's saying almost all portions. It does not cover. This is an introductory course, and this is a first year course for undergraduate students. So it is not expected to cover full syllabus of physical and mechanical metallurgy. I think you will have to study much more than what I am teaching you. I am teaching you the simple bits. You have to learn much more than that for GATE. Maybe in future we can plan for some GATE oriented course, but not this one. Shrikant tells me that whatever I have covered is part of the GATE syllabus, but then it is not whole of the GATE syllabus. It's only a fraction of the GATE syllabus. Maybe in future, not thinking about it. GATE syllabus will actually not a single course because GATE is supposed to cover a program. For example, GATE metallurgy is supposed to cover the entire B.Tech program for GATE, which will require several courses to cover the entire syllabus. So a single course will not be sufficient. Shrikant, you have done well in GATE. So why don't you give some tips for GATE? Hmm? I You can ask now. You can ask now. And Mohammed Sadiq, I am inviting the Shrikant to say something about the GATE preparation. He is expert in GATE exam because he has done very well in GATE. Come here, Shrikant. You can bring your chair. Can you speak? Hmm? Please say.
Okay, yeah. I prepared mainly from Dieter and Callister. So those were good enough for me. And
Detail for mechanical
yeah, the
and
mechanical
part of
metallurgy.
physical metallurgy, I think.
Yes.
For physical metallurgy, Reed Hill is also a good book. If you are preparing for any interview or exam and want to prepare for physical metallurgy, Reed Hill, mechanical metallurgy, Detail. These are two classics. I'll write the names there on this screen if you write this.
Yeah.
I'll come to your question, Dipankar, soon. First, let Shrikant write the names of the book.
What's there for that? Physical metallurgy.
Yeah, physical metallurgy. I don't know whether it's the name of the book, but that's the area of the book. Some introduction to physical metallurgy by Reed Hill. Original edition was by Reed Hill. Reed at the dash Hill there. Original edition was singly authored by Reed Hill. Now there are some co-authors as well. Yes, Deepankar, I will think that there should not be any change in the C by A ratio because our basic assumption is that during plastic deformation, there is no change in the crystal structure. And since there is no change in crystal structure, there should not be really any change in the C by A ratio either. In fact, not only the C by A ratio, C and A individually should not change. Mhm. Where? Sir, could you please suggest some references to understand twinning in HCP metal? But the reference which I gave for physical metallurgy, Reed Hill, which I had just shown, that's a good to start. They have a good discussion on twinning and in twinning with HCP metals also. And once you start with that, you will see more references. There are some references in that book as well. Hi Ankit, where are you from? Are they able to see each other's questions? Hmm? They are seeing. You also have registered as a student. Yes. Shantanu, your question, discussion of heat treatment of aluminum copper alloy and how to recognize intermetallic under SEM and TEM appears to be too general. I don't know how to answer this question. Maybe if you can be a little bit more specific, I can see if I can answer that or not. A very good book on annealing is a book by Recovery, Recrystallization and Grain. No, what is it? Recrystallization. A book by Recrystallization, book on recrystallization by Humphrey. So if I can write it down. The full title is Recrystallization and Related Annealing Phenomena. And what is the author's full name? Humphrey or Humphreys? S also is there. There are other co-authors also. Fatherly. Humphreys and Fatherly. A bit of mechanical metallurgy is coming now. In 10th week, we are starting with plastic deformation, and we will discuss plastic deformation in quite a bit detail. We will discuss creep, and we will discuss also fracture, and we will just touch a bit of fatigue. So all these are very introductory topics. If you really want to discuss fracture, if you really want to learn fatigue, you will have to go much deeper than that. But for somebody who has not heard of fatigue, this will be a first beginning introduction to fatigue. Similarly, somebody has not heard of fracture or has not heard of Griffith's equation will come to learn about it. So this is a very, very introductory course. No, I could not answer that question. Shrikant is asking whether I have answered how to recognize intermetallics. But is there any difference between dispersoid and intermetallic? Dispersoid is something which you are adding to an alloy as a as an external addition. Okay, so for example, thoria is dispersed in tungsten for bulb filament, in the older bulb filament. So we have thoria dispersion. So THO2 is a compound, is an oxide of thorium, which is dispersed. Whereas intermetallic compound is a compound of two elements. So Fe3C, for example, is an intermetallic compound, which is there in steel. But since it forms in situ when we are cooling the steel from austenite phase, then austenite decomposes into ferrite and cementite. So cementite forms inside the alloy itself. We are not externally dispersing. So Fe3C we will in steel we will call as intermetallic, but not as a dispersoid. So a dispersoid can be an intermetallic. If we disperse an intermetallic externally, we add an intermetallic into an alloy, then it can be called a dispersoid. So a dispersoid can be an intermetallic or may not be an intermetallic. The yield criteria like Tresca and von Mises, that actually goes into mechanical metallurgy. And in the book which I just referred, detail, that is discussed. In this course, we are not taking that up. Time is limited. We are already coming to an end. We have discussed many topics. So we are leaving this topic out. See, for hexagonal systems, the basal slip is one of the slip on the basal plane. On the basal plane in the closed path direction, that is one of the basic slip mode. And then you have slip on prismatic planes also. But the details of what a possible slip system is there in magnesium and how do they change up with alloying or heat treatment, I'm sorry, I'm not familiar. You will have to look up appropriate references. Good evening, Vicky. Are you in the lab? Precipitation hardening, to start with Reed Hill, the book of which I have already referred, has a chapter on precipitation hardening. And not aware of there is some full book on precipitation hardening, but I don't recall the name immediately. Essentially, you have to look at chapters in physical metallurgy books. There is a very famous physical metallurgy book edited book by Robert Kahn. But I don't know how these books one has to look in the library. These are not easily available in bookshops. Robert Kahn, Physical Metallurgy. Robert Kahn actually edited. Chapters by various authors. And I'm sure there will be Wiki, there will be a chapter on precipitation hardening, I'm quite sure, in this book. But if you come to me, I can walk walk you to the library and we can find many more books. Vicky, I'm talking to you. Eclipse Nova, welcome. Where are you from? Nova. Copy. Oh, you are from IIT Delhi. Welcome. You can see me sometime in person. We can have tea together. Good afternoon, Prashant. Thank you for Prashant. Thank you for appreciating my videos. I'll get you some tea and snacks for that. Join me after the session. And sorry for missing your presentation today. Oh, thank you if my videos are helping you in your exams. But before that, there was a question on a vacancy loops. So vacancy loop, let me try to explain. I have explained it in the video, bro, but maybe I can try it again here. Yes, Dipanshu Nova. Let me try to explain this. मीडियम नहीं है कोई, तो वो जो लाल है कलर कहाँ से? See, the whole idea, as I showed you in the video also, that if you have crystal lattice planes, so let us have crystal lattice planes. These are all planes with atoms on them. But suppose you now remove a part of the mid plane. Suppose that hole has been created. So that is a hole of vacancies. Then what will happen is, so if I draw it in a schematic now, if I draw it in the edge view, so you had planes like this. You had planes like this, and in one of the planes, I created a hole like this. Then you can see that the distance between the atoms here have become 2D, whereas here it was D. If you then if you now look at this situation, this will not be a very stable situation. So around the hole, the two planes above and below will collapse. Again, to make their equilibrium distance as D, just like it was here. So you have a situation like this. So you can see locally now, if you see, this is a plane which is abruptly ending, whereas these planes are continuing. So locally, this point is an edge dislocation. And this edge dislocation actually will go, because this was a hole, so it will be around this entire periphery. The entire periphery or circumference of this hole will be like an edge dislocation. But what is its Burgess vector? The Burgess vector is perpendicular to the loop. So B, if you find, will be that. So B is not in the plane of the loop, but perpendicular to the plane of the loop. This is what defines a prism. Because if you take the loop and the Burgess vector, you get a prismatic slip surface. The slip surface is prismatic, and that's why prismatic dislocation loop is what we call it. I hope it's clear. If not, anyway, you are in IIT Delhi, you can come and see me. I can try to explain to you better.
They ask for the reference
Who?
for SCM something.
Don't know. Karthik, you are teaching me some new information. So for this HCP metal, the C by A ratio less than 1.6, prismatic slip plane slips first, and then the basal plane. So I learned this from you, but why does this happen? I don't know. So you have to look at literature or research on this, or if nobody knows, you have to do the research. Are you a research student, Karthik? Because you are asking research-oriented questions. Saqib Ayub, are you well versed in thermodynamics of materials? Well, simple answer is no. Well versed is a very difficult question. Probably I'm not well versed in any subject, including the one which I am teaching. And definitely not in thermodynamics of materials. I've never taught the subject. You can't be well versed in a subject unless and until you teach it. Non-ferrous heat treatment. I think there are some book by ASM, but I don't remember the names. But heat treatment, there are. If you have access to good library, you can look at ASM handbooks, which have everything. ASM handbook, several volumes on all aspects. Materials. So Khushbu has a book on heat treatment. She will just share that with you. एक बार खुशबू को दिखला दीजिए कि वो लिख रही है. हाँ, वो तो वो लिख इसके ये लिख.
Say the name of the book.
Yes.
Yes.
Not years. It's probably by ASM, I think. The publisher is ASM, I think.
Yes. Why is whole pitch equation of value? Algorithm finding same course.
So the book is Heat Treatment, Structural Properties of Non-Ferrous Alloys by Charlie R. Brooks.
So Khushbu is an expert in heat treatment and metallurgy. She has done her PhD in modern nano-magnetic steel. So she can also guide you a lot, much more than me. What about this Hall pitch equation? Not valid. Very fine. Any answers? Hall pitch equation, do you know, Khushbu? Why doesn't it work for small grain size? This is a difficult question. Five. Saqib, Ayub, you have asked a difficult question. Why is Hall pitch equation not valid? For very fine and very coarse. For very small grain and maybe at relatively high temperature. Because if grain boundary is sliding, see, one problem is that the grain size dependence is coming because grain boundaries are obstructing the motion of dislocation. This is what we are assuming. But if this is not the main deformation mechanism, but grain boundary sliding is the main deformation mechanism, then the finer the grains, more the grain boundaries, and more grain boundary sliding will be happening. So the material will not become stronger by fineness of grain because you are providing it more sliding surface. So that can be one reason, but I'm not an expert in this area. So, and I have not done any detailed study. So I cannot answer your question confidently. Something I can look up. But I have no ready answer to provide you now. So Khushbu, you have received a thank from Shantanu. Dipanshu, oh, I didn't get you when you say that they are not uploaded in serial order with no topic name. Shrikant, we have some serious criticism from Dipanshu. The topics are not uploaded in serial order with no topic name as video name, which troubles us at some time.
Are you looking for the end?
No, but either at NPTEL or at YouTube, the video should have a topic name. But sometimes they are having only mod 1 or mod 2. Yeah, but see the next one. Mod 10 lecture 105.
And then 1 week.
Hmm?
This last week is not.
Mm-hmm. So the last, Dipanshu, it seems that we do have video names. No, means criticism, but suggestion. Let us say that what you are suggesting is important and we are giving due consideration to that, but we are also trying to understand what is really troubling you. Means videos have only number and not names, or what?
Order.
Maybe order is not exactly matching your course presentation order. This may be quite likely because a different instructor is teaching you the course, and I am teaching on this video. So the two may not exactly match. Two different instructors never follow the same sequence. And if I teach the same course many times, I don't follow the same sequence. So if that is the problem, then I'm sorry, but we can't do much about it. As a YouTube, see, Shantanu is saying that in YouTube topic name is not there. Why? Shantanu, my TAs are telling that only in the last week the topic name is not there. In the previous weeks it were there. Did you see in the previous weeks, or you didn't see names in the previous week also? So, hmm. Well, now we are coming to the end of the course anyway. So maybe one more session. Yeah, maybe one more session towards the end we can have after the 12th week. It's already 10th week is getting over. You have 2 more weeks to go. So we can have one more session after the whole course is over. Is our time already up?
No.
We started at 5. Anyway, questions are over, it seems. No one else is asking any new questions. अच्छा एक रत्नेश कुमार Ratnesh, hello, I missed you. I'm fine. How are you? Where are you from? Ratnesh? This is our Ratnesh. So Khushbu, you are good at references. So come up with a reference for. From a small icon, I am not able to realize that it is same Ratnesh Kumar Raj Singh, my ex-student, or it's some new Ratnesh. Flip से Nova. अरे क्या कर दिया तुम्हारा कंप्यूटर छू दिया Satnesh, yeah, before exam, I am thinking we will have one more session. We are coming close to the end of the session. If you have any other question, you can ask. Otherwise, we will close. Yeah, so I think Deepanshu is saying that it's mod 10. Mod 10 is the 10th week. No? So the 10th week video, you don't have the name. And there is one new name, Ravi Kiran. The Nana Ravi Kiran. And there is another Abhishek Kumar. So a lot of questions have come which we are missing. Sir, what is the use? Actually, your YouTube topic name is not there, but NPTEL portal. Then Abhishek Kumar, sir, what is the use of this course in manufacturing engineering? See, manufacturing engineering, you do manufacturing on material. And so the basic material properties and material structure will help you in manufacturing engineering. Ravi Kiran, why fine-grained structure is harder than coarse-grained structure? We are coming to that. So this is in the next week. Next week we have some slides on grain size strengthening of material. So we will come to that. So please wait for that. Lanana Ravi Kiran. Where are you from, Ravi Kiran? Ayub, which has a higher value of plane strain, higher value, plane strain fracture toughness or plane stress fracture toughness? Plane stress fracture toughness has higher value. But in this course, we have not discussed this. I teach another course, not on video, on fracture mechanics. So we discuss this in that course. Deepak Prince. from Jammu, appearing for Bar Metallurgy exam. All the best for your exam. Can you please make some short videos covering all important concepts and formulae? That's too challenging. My course, Materialopedia has been uploaded. We are going to upload one list of definitions, not a video, but a PDF file of list of definitions and concepts related to our course. I don't think it will cover all of your Bach metallurgy program, but based on our course, whatever concepts are there, you will find the definitions in one place. I have named it Materialopedia. So you may find it soon when Khushbu uploads it. Shrikant has to upload it. It's your responsibility, Shrikant. So please upload it soon. Odana Ravikiran from Visakhapatnam. Nice that you joined. I have very happy memories of Visakhapatnam. I like the Ramakrishna beach. Oh, Ayub, difficult to explain it in simple words here itself. But you can look up fracture mechanics book. If no other questions are there, we can say bye-bye. Thank you everyone for joining. Our list shows that 22 of you joined. Thank you very much. Thank you for taking interest in the course. Keep sending your feedback. Don't worry about being critical. We are planning to rerun the course, so any critical suggestions or any ideas for improvement are all welcome. We will try our best. We have made all this effort so that we can be of some use to you all out there. संदीप जी, आप भी आ जाइए, हेलो बोल दीजिए विजिटर्स को, बाय बाय तो बोल दीजिए, ऐसा नहीं कह सकते. So Sandeep ji also helps us. Yeah. There is a whole team at IIT Delhi. So I am there. Then Shrikant and Khushbu. Anyway, you keep knowing them from their answers and responses. And then Sandeep ji is there in the back room. He was the one who was recording the video. Unless and until videos are recorded well, it will not come out well for you. So he and there are others in the team who have worked very hard to make these videos in the IIT Delhi. And then there is a team at IIT Madras, which is running NPTEL. So all of them are there. We are there to help you out. So please utilize your whatever resources we are ready to offer to you. And with your guidance, with your suggestions, with your help, we will try to improve it more in future. So thank you. Bye-bye.